The Earth on which we live is surrounded by air. The layer of air that extends up to 1,000 kilometers from the Earth's surface is called the atmosphere. The gases that make up the atmosphere are what we will talk about today. How does the atmosphere move? And what does it do? Atmospheric general circulation. Atmospheric general circulation refers to the circulation of the atmosphere, which takes place across the entire globe. Through atmospheric general circulation, heat and water vapor are moved from the low latitude to the high latitudes, maintaining a balance of heat on the Earth. This balance is known as thermal equilibrium. So then, why and how does atmospheric general circulation occur? In order to understand atmospheric general circulation, we first need to properly grasp the concept of latitude. Let's place a protractor on the globe. To measure angles using a protractor, first you need to locate the horizontal line on the protractor that indicates 0 degrees, since this line is used as a reference for measuring all angles. On the globe, the horizontal line is at the equator. The Earth is divided at the equator into northern and southern hemispheres. The angles, 30 degrees, 60 degrees, and 90 degrees, from the equator are called degrees of latitude. The Sun is very far away from the Earth. Because the Earth is so small compared to the Sun, sunlight hits the Earth in horizontal lines. Near the equator, the rays of the Sun are more perpendicular to the ground, while at high latitudes, the Sun's rays reach the ground at an angle. This means that the same amount of sunlight hits only a small area at low latitudes, but is spread over a large area at high latitudes. We have all experimented with lenses, focusing pinpoints of light onto pieces of paper to make them burn. This experiment shows how the same amount of heat concentrated in a smaller area results in a higher temperature. The amount of energy received per unit of area is greater at low latitudes than at high latitudes, and this is why it is hotter in the tropics. At low latitudes, there is surplus energy, because the amount of heat radiated from the Sun is greater than the amount of energy radiated from the Earth. At high latitudes, there is an energy deficit, because the Earth gives out more energy than it receives from the Sun. This energy imbalance, caused by differences in energy received from the Sun and emitted from the Earth according to latitude, is one of the 2 causes of atmospheric general circulation. The other cause of atmospheric general circulation is the Coriolis effect, or the Coriolis force. The Coriolis effect is a force created by the rotation of the Earth that acts clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. The Coriolis effect is not an actual force. It only appears to exist. To understand the Coriolis effect, we need to look at atmospheric general circulation on the rotating Earth and on a hypothetical stationary Earth. First, let's pretend that the Earth is stationary and does not rotate. Warm air is lighter than cold air and has a strong tendency to rise. The air at the tropics is warm due to the high temperatures in the area and has a tendency to rise. However, this air cannot rise above the troposphere. With nowhere else to go, the air spreads out horizontally and moves to higher latitudes. At higher latitudes, the air is cooled, sinks down, and travels back down to the tropics, moving along the ground. Without the Coriolis effect caused by the Earth's rotation, we would have only a single circulation cell, with only northerly winds blowing across the surface of the Earth. So then, what happens on a rotating Earth? Here also, air rises in the tropics, then falls back down at high latitudes. However, when the heated air in the tropics rises and the cold air falls back down to the tropics, the Coriolis effect causes the flow of air to bend to the right, creating northeasterly winds. This is how the northeasterly trade winds are formed on the ground in the northern hemisphere. Due to the Coriolis effect, 3 circulation cells are formed in the atmosphere. These 3 circulation cells cause the trade winds, the westerlies, and the polar easterlies on the surface of the Earth. Let's look now at the winds and atmospheric circulation at the latitudes of 30 degrees, 60 degrees, and 90 degrees. First, 0 degrees and 60 degrees latitude are low-pressure zones with rising air currents. Here, there is a large amount of precipitation. At 30 degrees and 90 degrees latitude are high-pressure zones with descending air currents. At 0 degree to 30 degrees latitude, Hadley circulation causes the trade winds on the Earth's surface, while at 30 degrees to 60 degrees latitude, Ferrel circulation causes the westerlies. Lastly, at 60 degrees to 90 degrees latitude, polar circulation causes the polar easterlies. We mentioned before that the circulation of the atmosphere and seawater helps the Earth overcome latitudinal energy imbalances and maintain its constant temperatures. Now, we will examine the circulation of ocean surface currents. Surface currents are horizontal flows of seawater that continue to flow in a certain direction. Like the circulation of the atmosphere, these surface currents transport heat from low latitudes to high latitudes. Surface currents are caused by friction between the ocean surface and the winds that blow in a constant direction due to atmospheric general circulation. Surface currents in the northern and southern hemispheres are different. In the northern hemisphere, there are 3 kinds of circulation: tropical, subtropical, and subarctic. However, in the southern hemisphere, there are only 2 types of circulation: tropical and subtropical. Tropical circulation occurs near the tropics, moving in a counterclockwise direction in the northern hemisphere and a clockwise direction in the southern hemisphere. Subtropical circulation moves clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. The most important type of circulation, the North Pacific Subtropical Circulation, or gyre, can further be divided into the North Equatorial, Kuroshio, North Pacific, and California currents. Examples of subarctic circulating currents, found only in the northern hemisphere, include the North Pacific Current, the Alaska Current, and the Oyashio Current, also known as the Kuril Current. Why are there more types of circulation currents in the northern hemisphere than in the southern hemisphere? The reason is because the northern hemisphere has more continents. More continents means that the currents are more broken up. Now, let's look at the currents around Korea. However, before we do, let's talk a little more about warm currents and cold currents. Warm currents are sea currents that move from low to high latitudes, while cold currents are those that move from high to low latitudes. Warm currents are warmer and have a higher salt content than cold currents. The warm current near Korea is the Kuroshio Current. The Kuroshio Current, which is part of the North Subtropical Gyre, has the biggest impact on Korea. The Kuroshio Current results in the Yellow Sea Warm Current, the East Korea Warm Current, and the Tsushima Warm Current. The cold current near Korea is the Primorye Cold Current. The North Korean Cold Current is part of the Primorye Cold Current and flows southward toward Korea. This creates a boundary line in the East Sea where warm currents and cold current meets. And this is the reason why the Korean peninsula is surrounded by such rich fishing grounds. Today we study the atmospheric general circulation and the circulation of oceanic surface currents. It's amazing to think about how the air and water on this vast Earth are constantly moving. This might be a good time to bring up the issue of environmental pollution. Atmospheric pollutants, such as fine dust and smog, Water pollutants from garbage on land and oil leaks, and soil pollutants from chemical fertilizers, food waste, and household waste are also being circulated in the atmosphere and by the oceanic surface currents. It's a terrifying thought.